We are talking about system behaviors. We discussed the definition of behavior, which is the way in which living things, person, one acts or conduct oneself. This is for human being. Second, for animals, acts in response to a particular situation or stimulus. Third, in non-living things, a natural phenomenon or a machine works or functions. Okay. Now we give emphasis more on the definition of behavior, meaning the observable performance or changes relating to properties or forms of non-living things as evidenced from their work or functions or changes by times. The work of the car, the work of the computer, the machines, and anything at all which are not living things. Okay. Now, in terms of system behaviors, we may say that it's the act of a system resulted from the change of components from its conception, existence, and entropy. Entropy means the end, the dissolution of what exists. Okay. What is the composition of system behavior? System behavior comprises, first, working performance of the system. Second, the change of the system. Third, the changes on due time or age of the system. Okay, three things. Now, when you study the system behaviors, how can you do it? The system behaviors can be done, the study of the system behavior can be done first by investigating the system components. Have a good look, have a careful look of the AC. Second, you observing the interaction of the system components. Third, investigating the system outcomes. Fourth, analyzing the properties of the components. Four things, okay? Now, the study of the system behaviors may be based on two things. Remember? Structural concept and processing concept. Okay. So when we study system behavior, you may have a look at the structural concept or processing concept of the system component. Now, for the study of system behaviors basing on the structural system component, we call it SSC, structural system component. We have a look at three things: boundary and environment. Boundary, boundary is something that you have to understand. You cannot go beyond that, because boundary and environment, anything surrounding you. And then second, the interactions of structural system components, because as we mentioned that all components work together. See, they cannot fly around on its own. They have to work together. And then third, we have to look at the layer, the hierarchy, system, subsystem, sub-subsystem. We call hierarchy. Okay, three things. Now, basing on system attributes, The study of system behaviors may be through looking at the system conditions. There are 4 system conditions. First, system quality. Second, systems security. Third, interrelations of the internal components of a system. And fourth, system dimension. The study of system behavior by considering the process may be considered via the treatments of various components such as dynamics and change. Second, rules and regulations and system maintenance. Third, system depreciation. Depreciating means getting worse. Okay. And fourth, systems entropy towards disorder and dissolution. Entropy means disappear. Our life, entropy will die. You cannot breathe anymore. Systems dynamics is first and change. System dynamics and change are the non-static and ongoing changes by passing time and changing environments such as self-adjustment and learning. Second, identifying goals, whether you need to have low goal or moderate goal or high goal. Okay. Now, after we have talked about that, we talk about regulations, rules and regulations, and system maintenance, which is the second aspect. Rules and regulations are related to the system concerning the following things. 6 things: goals, emergent properties, feedback. There are 3 or 4 types of feedback: positive feedback, negative feedback, or byproducts, or unexpected outcomes. Byproduct outcomes or unexpected outcomes. What we worry about when you develop a system, that because of experiences you may not foresee clearly the unexpected outcomes. For example, in Thailand, we use pork oil for cooking. We use coconut oil for cooking for thousands of years. Suddenly, the Western product comes. The products of soybean, by the way, it turned out to be we call oil from the palm, oil from palm, oil from the soybean, so on and so forth. We call vegetable oil. Usually, vegetable oil are no harm, are not harmful. But when you put into the bottle, you can see the lump, they are not clearly flow. So the innovators got some really good idea. So they spray hydrogen into it. We call processed vegetable oil. Then the content of the oil turned out to be very clearly and beautifully visible, and put in the bottle. So Thai people, believing that they got the best, better than pork oil or coconut oil, start to use vegetable processed vegetable oil for cooking. 20, 30 years gone. And then the researcher found out that the process hydrogen spray vegetable oil are the cause of cancers. Thai people consuming processed vegetable oil turn out to be the victims of cancers among top of the whole world, because they don't expect, they had not expect the outcomes, the harmful, the dangers of the processed vegetable oil. The same as the cream they put in coffee, the same thing. You see, I'm one who my favorite is to use the cream to put in coffee. Okay. Now we talk about the rules and regulations that we need to consider concerning goals, emergent properties, anything coming up later on, feedback which are positive, negative, byproduct outcomes, or unexpected outcomes. Now the fourth one is mechanism for system equilibrium and security. Equilibrium means balancing, to make sure that the system exists as long as possible. Okay. And the fifth one is system controlling. And then system communication. System communication, you get the idea? Or the system component, each of them communicate to each other. You can see if you have the gear and it turn out one or two of the gears start to be broken, you cannot send the force towards the second one. The motors, how big, how hard, how strong it is, they cannot convey the power to the other part of the machine. So. Now the last one, system depreciation and entropy. We talk about three things. Quality, depreciation by times or by ages. When you buy something, you buy the machine, you buy the car, the first 6 months or the first year, it will run very smoothly. No problem at all. Or when you buy your cell phone, the same thing. Then, second, disruption caused by non-performing elements. When the time's gone, there might be some disruption because of some of the components in the machine here does not perform. We call non-performing elements. They does not perform the work, the functions as they're supposed to. Okay. Now the third one about the system depreciation and entropy, loss or worn out of some of major components. It's the same thing as I have mentioned. Okay. So the three things: quality, depreciation by times or by ages, disruption caused by some of the elements do not perform as is expected, and loss or worn out of some of major components are the causes of entropy. Entropy means the dissolution or the end of the system. Okay, now let's talk about system behaviors by process. Okay. By process, system behavior comprise 6 things that you have to keep in mind. First, system maintaining. You have to maintain it. You have to prolong your system to make it as long as possible. We call system prolonging or maintaining. And in order to do so, you have to maintain it. You have to have maintenance, keeping up, fixing it, okay, repairing it. So we call system maintenance. The third, system controlling. You have to have an eye on the type of elements, the type of component, context, input, process, output, and feedback. Fourth, system balance and security. Should understand that. Fifth, system modification according to the feedback. And sixth, last one, system prevention from depreciation and entropy. So in terms of system behaviors by process, you have to have a look at 6 things. Okay, prolonging the system to run as long as possible by maintaining it, by repairing it, fixing it, and controlling it, keep it balanced, and keep it safe, security. And then when you get some feedback whatsoever, you have to fix it. You have to modify the component or the system. And lastly, you have to come up with prevention or mechanism to prevent it, to prevent your system from depreciation and entropy. So this is the end of our first series of systems on system concept. We have 3 separate clips. And thank you for watching. And now go back to your group and work on developing or creating your own system. In this case, you have to develop an education system for your college, for your virtual college or your virtual school. Okay, good luck. Thank you so much. Bye.